This is SpaceTime Series 25, Episode 75, for broadcast on the 8th of July, 2022. Coming up on SpaceTime, a Martian meteorite upsets planetary formation theory. Another 6 space tourists kiss the edge of space aboard New Shepard. And SpaceX rounds off a busy launch schedule with more than a dozen flights. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study based on an old Martian meteorite is contradicting current ideas about planetary formation. The findings, reported in the journal Science, brings into question existing hypotheses on how the terrestrial worlds, planets like the Earth, Mars, Venus, and Mercury, acquire their volatile elements, such as hydrogen, carbon, oxygen, nitrogen, and noble gases, as they form. The basic assumption about planetary formation is that planets first collect these volatiles from the protoplanetary nebula surrounding a young forming star. Different elements condensate out of the nebula at different temperatures and consequently at different distances. Now, because the forming planet is still a ball of molten rock at this point, these elements initially dissolve into the magma ocean and then degas back into the atmosphere. Later on, chondritic meteorites crashing into the young planet deliver more of these volatile materials. So, scientists expect that the volatile elements found in the interior of the planet should reflect the composition of the solar nebula, or at least a mixture of solar and meteoritic volatiles, while the volatiles in the atmosphere would come mostly from meteorites. These two sources, solar and chondritic, can be distinguished by the ratios of isotopes of noble gases, in particular krypton. Mars is of special interest here because it formed relatively quickly, solidifying during the first 4 million years since the birth of the solar system 4.6 billion years ago. On the other hand, it's thought the Earth took a lot longer, between 50 and 100 million years to form. Remember, it had to deal with an interplanetary crash with the planet Theia, which would eventually form the Earth-Moon system as we know it today. The study's lead author, Sandrine Perron from the University of California, Davis, says scientists can reconstruct the history of volatile delivery for the first few million years of the solar system, and they know that some meteorites that fell on Earth came from Mars, and most of those came from surface rocks that had been exposed to the Martian atmosphere. However, one meteorite which fell to Earth in northeastern France in 1815 is rare. That's because it's thought to represent the interior of the red planet, rather than just some surface rock that was ejected into space following an asteroid collision. Perron and colleagues studied this meteorite, making extremely careful measurements of minute quantities of krypton isotopes in samples of the meteorite using a new method set up at the UC Davis Noble Gas Laboratory in order to determine the origin of the elements in the rock. But they were shocked to find that the krypton isotopes in the meteorite corresponded to those from chondritic meteorites, not the solar nebula. That means that meteorites were delivering volatile elements to the forming planet much earlier than previously thought, and in the presence of the nebula, reversing conventional thinking. Perron says the Martian interior composition for krypton is nearly purely chondritic, but the atmosphere is solar, and the difference is very distinct. The results show that the Martian atmosphere can let it form purely by outgassing from the mantle, as that would have given it a chondritic composition. So the planet must have acquired atmosphere from the solar nebula directly after the magma ocean cooled, in order to prevent substantial mixing between interior chondritic gases and atmospheric solar gases. The new results suggest that the red planet's growth was completed before the solar nebula had been dissipated by radiation from the sun. But the problem is, the irradiation would also have blown off the nebular atmosphere on Mars, suggesting the atmospheric krypton must somehow have been preserved, possibly trapped underground or in the polar ice caps. And the thing there is, that would have required Mars to be really cold in the immediate aftermath of its creation. While this study clearly points to contradicting gases in the Martian interior, it also raises some interesting questions about the origin and composition of the early Martian atmosphere. And eventually, these too will need to be addressed. This is Space Time. Still to come, another 6 space tourists kiss the edge of space aboard New Shepard, and the first Ariane 5 launch for 2022. All that and more still to come on Space Time. Blue Origin has undertaken its 5th manned space tourism flight. The New Shepard launch vehicle and capsule carried 6 passengers on the 10-minute ride from the company's West Texas launch pad up to the edge of space.
This is the flight director on Channel 1 and UHF voice for the go poll for terminal count and launch. Capsule.
Go.
Booster.
Go.
Ground.
Go.
Safety.
Go.
Capcom.
Go.
Engineering. Go. First step, this is your flight director, New Shepard, is go for launch. Booster, commence the terminal count.
The aft fins, those fins at the base of the vehicle that help direct the vehicle on ascent and descent, exercising their full range of motion. The BE-3 propulsion module nozzle gimbaling, this is the primary form of control for the vehicle on ascent and of course for landing, doing a full range of checks, ensuring free range of motion. Those tanks are at pressure. There's variables for pressure and temperature on the cryogenic tanks in the green zone. That's what they're watching in mission control.
T-minus 10, 9, 8, 7, 6, 5, 4. Command engine start. 2, 1.
Liftoff at 3,700 feet above MSL. That's about how far we are above sea level out here in Launch Site 1.
And that BE-3 engine rumble really coming through as the vehicle approaches the maximum dynamic pressure, the point where the aerodynamic stresses on the vehicle are at their maximum. That BE-3 engine will throttle back just a little bit. Max Q. Here in about 30 seconds, Kaya will see the BE-3 PM engine shut off for main engine cutoff, Miko.
And Miko, main engine cutoff. The vehicle is now coasting at over 2,000 miles per hour.
Okay, we should have separation of the capsule and the booster here momentarily. Laura Stiles will cue the astronauts to unbuckle their harnesses and start floating around the capsule. Victor Vescovo, Katia Chaserreta, Hamish Harding, Jason Robinson, Victor Correa España, and Evan Dick are now in 0G.
We just received confirmation the crew capsule's apogee of 351,183 feet.
Well, Kaya, it really sounded like they were having a lot of fun in that 15 cubic meter cabin. Congratulations to all 6 crew. They just officially became astronauts. Outstanding.
Both the crew capsule and the booster are now descending.
And we'll follow the booster first for landing. That rocket is now reaching its atmospheric pierce point, returning from space and entering the atmosphere. The control surfaces of the fins are now starting to have air pressure to push against and to navigate to over the landing pad.
And that booster is now reaching its maximum re-entry velocity, which is just under Mach 4. The booster's shape causes a lot less drag than the crew capsule, so it'll win the race back down to the ground.
The wedge fins, steering fins, and ring fin really earning their keep at this point in the flight.
The air brakes are deploying here. It's just such a critical step in slowing the vehicle down. Velocity starts to decrease very rapidly. You can follow along on the top right corner of your screen, and we just heard the sonic booms.
Loud and clear. And there's the PM engine relit confirmed, coming down for a nice soft landing.
And booster touchdown. Welcome back, New Shepard.
For a lot of us at Blue, this moment in flight is one of the main highlights as it shows off the incredible engineering required to bring a rocket back safely home from space, ready to be reused.
Our 6 astronauts right now, they're sitting in their capsule, enjoying the view as it slowly descends down. And here are the drogues deploying now. These drogues will slow the capsule down in preparation for the 3 main chutes.
And there we have it, the 3 main chutes.
While those beautiful parachutes are essential in providing a gentle touchdown for the crew capsule, New Shepard also has an innovative retro thrust system on the bottom of the capsule to make the touchdown even smoother for our astronauts flying today. And as that capsule slowly descends, that retro thrust system soon will fire moments before touchdown to slow the capsule down even further, just to 1 or 2 miles per hour. And touchdown. Welcome back to Earth, New Shepard's astronauts. They just went to space and they are back.
The suborbital flight reached an apogee of 107 kilometers, well above the 100-kilometer Kármán line, marking the internationally recognized official start of space. The flight had been delayed by several weeks because of a problem with one of the spacecraft's backup systems. This is SpaceTime. Still to come. Ariane Space undertakes its first Ariane 5 launch for 2022, and SpaceX rounds off an incredibly busy launch schedule, undertaking more than a dozen flights in just a few weeks. All that and more still to come on SpaceTime. The European Space Agency has undertaken its first Ariane 5 flight for the year, placing 2 telecommunications satellites into geostationary orbit. Ariane Space Flight VA257 transported Malaysia's Meteosat 3D and the Indian Space Research Organisation's GSAT-24 spacecraft. The successful launch from the Kourou spaceport in French Guiana also marked the 5th last mission for the current Ariane 5 launch vehicle, which is being replaced by the new Ariane 6 early next year. The 5,600-kilogram Meteosat 3D is a multi-mission telecommunications satellite built by Airbus Defence and Space, designed to increase high-definition 4K and ultimately 8K broadband satellite capacity across the Asia-Pacific region. The spacecraft's also carrying a separate payload for the Korean Space Agency, which is designed to improve local air traffic control operations for the South Korean Ministry of Land Infrastructure and Transport. Meanwhile, the Indian GSAT-24 is a 4,180-kilogram 24Ku band telecommunications satellite built by the Indian Space Research Organisation ISRO for New Space India. The successful flight comes as ESA reorganises many of its scheduled manifests for the year in the wake of the agency's decision to cut all operational ties with Russia as a result of Moscow's ongoing attacks against Ukraine. Ariane Space originally had 3 levels of launch vehicle. There was the Ariane 5, soon to be replaced by the Ariane 6 as the heavy launcher. The Russian Soyuz was being used as a medium-lift launch vehicle. And the Vega, soon to be replaced by the Vega C, was designed to take care of small launch payloads. Missions previously scheduled to fly on contracted Roscosmos Soyuz flights have now all been cancelled and will progressively need to be slotted into new flight schedules using either Ariane or Vega launch vehicles instead. This is SpaceTime. Still to come, SpaceX rounds off a busy launch schedule with more than a dozen flights. And in July, Skywatch, planet Earth reaches its furthest orbital position from the Sun. We look at the spectacular Southern Cross constellation, and we study the ticking time bomb known as Antares. All that and more still to come on SpaceTime. Well, it's been busy times for SpaceX and its Falcon 9 workhorse, with more than a dozen launches taking place on what seems to be a futuristic space-age production line with, well, quite literally one launch after another. On June the 21st, SpaceX launched 3 Falcon 9s in the space of just 36 hours. The company's 26th launch of this year blasted off from the Cape Canaveral Space Force Base in Florida, carrying a new 700-kilogram telecommunications satellite for Louisiana-based Global Star. That was the 9th launch for the same Falcon 9 core stage, which returned safely to Earth, landing on the drone ship Just Read the Instructions, which had been pre-positioned downrange in the North Atlantic Ocean. It followed the launch of a new radar satellite for the German military from Space Launch Complex 4 East at the Vandenberg Space Force Base in California. And just a few hours earlier, SpaceX launched 53 Starlink internet satellites aboard a Falcon 9 from Pad 39A at the Kennedy Space Center, literally just down the road from where the Global Star satellite was to be launched. The Starlink mission marked the 100th successful launch using a previously flown and refurbished Falcon 9 core stage. And again, this core stage returned safely to the drone ship, a short full of gravitas. Meanwhile, a week earlier, another Falcon 9 launch from Cape Canaveral delivered the NALSAT 301 satellite into geostationary transfer orbit, with that core stage also successfully returning to Earth and landing on the drone ship Just Read the Instructions. A few weeks earlier, SpaceX had used the same launch pad for its Transporter 5 rideshare mission, carrying more than a dozen small CubeSats, microsatellites, and nanospacecraft into a range of sun-synchronous orbits. Also on board that flight were the cremated remains of 47 people who wanted to be buried in space. A week earlier, another Falcon 9 undertook a launch carrying a further 53 Starlink satellites into orbit, also using Space Launch Complex 40 at the Cape. That mission, which had been delayed by stormy weather, also saw the Falcon 9 core stage return safely to Earth, landing on the drone ship Just Read the Instructions. That was the 12th time the same booster had been used for a launch. Meanwhile, another Falcon 9 carrying another 53 Starlink satellites blasted off from the adjacent launch complex 39A. The core stage of that mission also returned safely to Earth, landing on the drone ship, a short full of gravitas. And days earlier, another 53 Starlink satellites were placed into orbit following a successful launch from the other side of the country at the Vandenberg Space Force Base in California. Again, the Falcon 9 core stage safely returned to Earth, landing on a pre-positioned drone ship. Another batch of 53 Starlink satellites had been launched days earlier from Cape Canaveral, this one marking the second flight for the same Falcon 9 core booster, which had just returned from space 21 days earlier. And it won't be the last, with the booster landing safely on the drone ship Just Read the Instructions. Meanwhile, another 53 Starlinks were launched in late April from the Cape, with the core stage undertaking its 12th landing, also touching down safely on the drone ship Just Read the Instructions. That mission was the 43rd launch related to the Starlink project. A few days earlier, the top-secret National Reconnaissance Office NROL-85 mission was launched aboard another Falcon 9 rocket from Vandenberg. The core stage returned to Earth 8.5 minutes later, touching down safely on Landing Zone 4. It was the 4th dedicated launch for the National Reconnaissance Office, which is charged with the responsibility of operating the United States fleet of spy satellites. It was also the 2nd launch for the same booster core stage, which had previously flown the NROL-87 spy satellite mission. Although the National Reconnaissance Office doesn't release details of their clandestine space flights, orbital trajectory details can be used to infer what sort of satellite was launched. And based on the latest orbital trajectory details, it suggests that this launch was of a Naval Ocean Surveillance System intruder satellite. These usually operate in pairs, scouring the Earth's oceans for radio transmissions which they can then triangulate in order to pinpoint the exact position of naval vessels. Around the same time, SpaceX also launched 2 manned Dragon flights to the International Space Station. These were the Axiom 1 mission and NASA's Crew 4 astronaut transfer mission, both flying off Pad 39A at the Kennedy Space Center. Now, this incredibly intense launch schedule all began back on April the 1st, when the SpaceX Transporter 4 mission, carrying a manifest of 40 payloads, including a fleet of small nano and micro satellites, as well as multiple CubeSats, was sent into orbit. The payloads were delivered into a series of sun-synchronous orbits. The largest spacecraft on the rideshare mission was the 980-kilogram Environmental Mapping and Analysis Program, or ENMAP, German hyperspectral satellite, which will be used to monitor and characterize the Earth's environment. Also included in the manifest were 4 CLEOS Space Patrol mission satellites, 4 Satellogic updated NewSat Mark IV satellites, as well as the new Mark V satellite fitted with visible and infrared Earth imaging equipment. Then there was the D-Orbit Ion Satellite Carrier Vehicle, the almighty Alexis, a free-flying self-propelled CubeSat transfer tug designed to host or deploy up to 8 payloads into specific orbits. Other payloads include 3 CubeSats from the University of Chile, 3 Hawkeye 360 Hawk 4A, B and C transportation monitoring satellites, a Norwegian Defence Research Establishment satellite, and several dozen smaller microsatellites and CubeSats. The first stage of the mission returned safely to Earth, landing on the drone ship Just Read the Instructions, which had been pre-positioned 532 kilometers downrange in the North Atlantic Ocean. Certainly a busy launch schedule for SpaceX. This is Space Time. And time now to turn our eyes to the skies and check out the celestial sphere for July on Skywatch. July is the 7th month of the year in both the Julian and Gregorian calendars, and is named after the Roman Emperor Julius Caesar, who was born during the month. Before being called July, the month was called Quintilis, which is Latin for 5th. The addition of the months January and February brought an end to that. On average, July is the coldest month in the year in the southern hemisphere, which is experiencing winter, and also marks the time when Earth is at aphelion, its furthest orbital position from the Sun. Of course, temperatures, or more accurately seasons on Earth, aren't dictated by the distance from the Sun, but rather the length of a day, and hence the amount of sunlight a given part of the Earth receives, which is governed by the tilt of Earth's axis. Consequently, that's why July is on average the warmest month in the Northern Hemisphere, which is currently experiencing summer. During this aphelion, Earth will be 152,098,455 kilometers from the Sun. That's about 5 million kilometers further away than during perihelion back in January. This year's aphelion occurred at 5:10 in the afternoon on Monday, the 4th of July, Australian Eastern Standard Time. That's 3:10 in the morning US Eastern Daylight Time and 7:10 a.m. Greenwich Mean Time. Over cosmic time, these dates change. That's due to variations in Earth's orbit, such as eccentricity, as well as axial tilt and precession, which all follow regular cyclic patterns known as Milankovitch cycles. Eccentricity involves changes in how elliptical Earth's orbit is around the Sun. None of the planets actually orbit the Sun in perfect circles, although Venus and Neptune are the closest. Instead, they all have elongated orbits which vary over time. As well as that, Earth spins on an axis which is currently tilted at 23.4 degrees compared to the ecliptic, Earth's orbital plane around the Sun. But this angle of tilt also changes over time, influenced by, among other things, the distribution of the Earth's mass. And just like a spinning top, the rotational axis of the Earth also changes its orientation through a process called precession, changing its position in relation to fixed background stars over a 26,000-year cycle. Now, all these effects impact the amount of solar radiation reaching the Earth, what time it reaches the Earth, and consequently the planet's seasonal and climatic patterns. Right now, the Southern Cross is at its highest point in the southern sky, and is pointing directly towards the southern celestial pole. The Southern Cross falls within the constellation Centaurus the Centaur, the half-human, half-horse of Greek mythology, and the creature is holding a bow loaded with an arrow. The Centaur's front legs are marked by the 2 pointer stars, Alpha and Beta Centaurus. At 4.3 light-years, Alpha Centauri is the second of the 2 pointer stars from the Southern Cross, and is also the nearest star system to the Sun. The Centaur's back arches over the Southern Cross, and just above this is Omega Centauri, a spectacular globular cluster, visible with the unaided eye from dark locations. Globular clusters are tightly packed spheres containing thousands to millions of stars. They're thought to have all originally been born at the same time from the same molecular gas and dust cloud, or they're the cause of small galaxies which have been consumed by bigger galaxies through galactic cannibalism. Omega Centauri is about 16,000 light-years away. A light-year is about 10 trillion kilometres, the distance a photon can travel in a year at 300,000 kilometres per second, the speed of light in a vacuum, and the ultimate speed limit of the universe. Omega Centauri is one of the largest and brightest of the 150 or so globular clusters known to orbit around our Milky Way galaxy. Centaurus was one of the 48 constellations listed by the 2nd century astronomer Ptolemy, and it remains one of the 88 modern-day constellations. Turning to the right or west, and you'll see the constellation Leo the Lion, just above the western horizon. Its brightest star is Regulus, or the Little King, located about 79 light-years away. Regulus, designated Alpha Leonis, is actually a 5-star system, organized into 2 pairs. Regulus A is a spectroscopic binary, comprising a spectral type B blue-white main sequence star, some 4 times the mass and 288 times the luminosity of the Sun, and a faint companion star thought to be a white dwarf, the stellar corpse of a Sun-like star. Spectroscopic binaries are stars that can't be resolved by optical telescopes into 2 separate objects, and can only be separated by observing their individual spectroscopic Doppler shifts as they orbit each other. Astronomers describe stars in terms of spectral types, a classification system based on temperature and characteristics. The hottest, most massive and most luminous stars are known as spectral type O blue stars. They're followed by spectral type B blue-white stars, then spectral type A white stars, spectral type F whitish-yellow stars, spectral type G yellow stars, that's where our Sun fits in, spectral type K orange stars, and the coolest and least massive known stars are spectral type M red dwarf stars. Each spectral classification is also subdivided using a numeric digit to represent temperature, with 0 being the hottest and 9 the coolest, and a Roman numeral to represent luminosity. So put all that together, and our Sun is a spectral type G2V or G25 yellow dwarf star. Also included in the stellar classification system are spectral types L, T and Y, which are assigned to failed stars known as brown dwarfs, some of which were actually born as spectral type M red dwarf stars, but became brown dwarfs after losing some of their mass. Brown dwarfs fit into a category between the largest planets, which can be about 13 times the mass of Jupiter, and the smallest spectral type M red dwarf stars, which can be 75 to 80 times the mass of Jupiter, or 0.08 solar masses. Located further away are Regulus B, C and D, which are dim main sequence stars. At the opposite end of the constellation from Regulus is the star Beta Leonis, or Denebola, the horse's tail. It's also a luminous blue-white star, about half as bright as Regulus, and the 3rd brightest star in the constellation Leo. Beta Leonis has about 1.8 times the Sun's mass and about 15 times the Sun's luminosity. It's suspected of being a dwarf Cepheid or Delta Scuti type variable star, meaning its luminosity varies slightly over a period of several hours due to pulsations on its surface. Algebra or Gamma Leonis is a binary system with a visible 3rd component. The 2 primary stars are located about 126 light-years away and can be resolved in small backyard telescopes. Both are yellow giants orbiting each other every 600 Earth days. The unrelated tertiary star named 40 Leonis is a yellow tinge star that can be seen through binoculars. The star's traditional name Algebra means forehead. Delta Leonis or Zosma is a blue-white star 58 light-years from Earth. Epsilon Leonis is a yellow giant some 251 light-years from Earth. And Zeta Leonis is an optical triple star. The brightest component is a white giant about 260 light-years from Earth, while the second brightest star, 39 Leonis, is widely spaced and located to the south of the primary. The 3rd and faintest star in the system, 35 Leonis, is to the north. Lota Leonis is a binary star system visible in medium-sized backyard telescopes. Located some 79 light-years away, Lota Leonis appears to be a yellow tin star with 2 components orbiting each other every 183 Earth years. Finally in Leo, let's look at Tau Leonis. Visible as a double star through binoculars, it includes a yellow giant located some 621 light-years from Earth, and binary secondary star 54 Leonis, which is actually a pair of blue-white stars that are visible in small telescopes and located some 289 light-years away. The constellation Leo also contains many galaxies, including the spiral galaxy Messier 66, as well as Messier 65 and NGC 3628, which are known as the Leo triplet. Located some 37 million light-years away, the Leo triplet has a somewhat distorted shape due to gravitational interactions between Messier 66 and the other two galaxies, which are cannibalizing stars from Messier 66. Eventually, the outermost stars may well form a dwarf galaxy orbiting M66. Both M65 and M66 are visible in large binoculars or small backyard telescopes, but their concentrated nuclei and elongation are only visible in larger instruments. Other bright, well-known deep sky galaxies in Leo include Messier 95, Messier 96, and Messier 105. Messier 95 and Messier 96 are both spiral galaxies, each about 20 million light-years from Earth. Both look like fuzzy objects in small telescopes, but display their spectacular structures in larger instruments. M95 is a barred spiral. Another barred spiral, NGC 2903, is thought to be similar in size and structure to our own Milky Way galaxy. It was discovered by William Herschel in 1784. Close to the M95-M96 pair is the elliptical galaxy M105, which is also about 20 million light-years away. The constellation also contains the Leo Ring, a cloud of hydrogen and helium gas orbiting two of the galaxies in the constellation. A gravitationally lensed object known as the cosmic horseshoe is also found in Leo. Above Leo, you'll find the constellation Virgo, the Greek and Roman goddess of wheat and agriculture. Virgo's brightest star, Spica, is visible above the western horizon. It's located some 250 light-years away. Spica is Latin for ear of wheat, which Virgo is holding in a hand. Spica, or Alpha Virginis, is the 16th brightest star in the night sky, and is both a spectroscopic binary and a rotating ellipsoidal variable, a close binary system whose stars are not eclipsing but cause apparent fluctuations in brightness because of changes in the amount of light emitting area visible to the observer. Spica's two main stars orbit each other once every 4 Earth days and are so close they're egg-shaped rather than spherical and can only be separated by their spectra. The primary is the blue giant variable Beta Cepheid star. It undergoes small rapid variations in brightness. These are caused by pulsations of the star's surface, thought to be caused by the unusual properties of iron at temperatures of 200,000 degrees in the stellar interior. It has about 10 times the Sun's mass and about 7 times its diameter. The secondary star in Spica is smaller than the primary, but it's still some 7 times more massive than the Sun and has 3.6 times the Sun's diameter. Turning to the north now, and the constellation Boötes, the herdsman or ploughman. There you'll see the bright orange-red star Arcturus, or Alpha Boötes, just above the northern horizon. It's a red giant located just 36 light-years away, a bloated, aging star some 7.1 billion years old, nearing the end of its life. Although not much more massive than the Sun, it's now expanded out to some 25 times the Sun's diameter and will soon puff off its outer gaseous envelope as a planetary nebula, revealing its white-hot stellar core, a white dwarf, which will then slowly cool over the eons of time. Another bright reddish-looking star, this time in the east, is the red supergiant Antares, meaning the rival of Mars, because of its appearance and location in the sky, which appears to be opposite of Mars in the sky. Antares is one of the biggest known stars in the universe. It's enormous, 18 times the Sun's mass, 10,000 times its luminosity, and 883 times the Sun's radius. As we mentioned in last month's Skywatch, were it placed at the centre of our solar system, its surface would extend out close to the orbit of Jupiter. Despite being some 550 light-years away, Antares is still the 15th brightest star in the night sky. Unlike the Sun or Arcturus, the death of Antares will be far more spectacular. Antares is destined to explode as a core collapse or Type II supernova. When it does so, sometime in the next few 100,000 years, it'll appear as bright in the Earth's sky as the full moon and be quite visible even in daytime. Antares has a companion star, Antares B, a spectral-type blue-white main sequence star more than 7 times the Sun's mass and 5 times its diameter. Antares is the heart of the Scorpion in the constellation Scorpius. Below Scorpius is the constellation Sagittarius, the Archer, which points the way to the centre of the Milky Way galaxy. Sagittarius is commonly represented as a winged centaur, pulling back on a bow which is aimed at Arcturus. The centre of the Milky Way galaxy and its supermassive black hole Sagittarius A star lie at the westernmost part of Sagittarius. Sagittarius A star is about 27,000 light-years away and has some 4.3 million times the mass of our Sun. It was in July back in 2016 that the solar system's barycenter moved outside the Sun, where it will remain until 2027. A barycenter is the gravitational center of mass of a celestial system. For example, in our Earth-Moon system, the Earth and Moon actually orbit each other around a common center of gravity, a barycenter. Now, because the Earth is so much more massive than the Moon, the barycenter is always inside the Earth's radius. If it were outside the Earth's radius, the Earth and Moon would instead have been classified as a binary planetary system, like Pluto and Charon. The solar system's center of gravity or barycenter is usually located inside the Sun's radius. After all, the Sun contains over 99% of all the solar system's mass. But actually, the mass of the solar system is orbiting around the solar system's barycenter, which means the Sun also has a very slight spiraling 12-year orbit around the barycenter. And every now and then, when the planet's orbital positions are just right, especially when Jupiter and Saturn are nearest each other, their combined gravitational interactions move the solar system's barycenter ever so slightly outside the Sun's radius. And because Jupiter and Saturn reach this alignment every 11 years, some scientists have speculated whether this could trigger the Sun's 11-year solar cycle. And before you ask, the barycenter isn't named after some guy in a beige safari suit called Barry, but rather it's the ancient Greek word for heavy or center of mass. We also have 2 meteor showers, both of which peak in late July. There's the southern Delta Aquarids, which are visible from mid-July to mid-August each year, with peak activity on July the 28th and 29th. The shower originated either from the breakup of what are now the Marsden and Crack sun-grazing comets, or from the parent comet P96 Malkolts. The Delta Aquarids get their name because their radiant appears to lie in the constellation Aquarius, near one of the constellation's brightest stars, Delta Aquarii. There are 2 branches to the Delta Aquarids meteor shower, the southern and northern. The southern Delta Aquarids are considered a strong shower, with an average of between 15 and 20 meteors an hour between midnight and dawn. Listeners in the southern hemisphere usually get the better show because the radiant is higher in the southern sky. Since the radiant is above the southern horizon for northern hemisphere listeners, meteors will be seen to fan out in all directions east, north and west, with few meteors heading southwards, unless they're really short near the radiant. The northern Delta Aquarids are the weaker shower, peaking later in mid-August, with an average peak rate of about 10 meteors per hour. Meanwhile, the nearby slow and bright Alpha Capricornids meteor shower will take place from as early as July the 15th, and continue until around August the 10th. The meteor shower has infrequent but relatively bright meteors and even some fireballs. It's generated as the Earth passes through a debris trail left by the comet 169P NEAT, which was originally identified as the asteroid 2002 EX12. However, it was shown to be weakly active during perihelion and was then reclassified as a comet. The meteor shower was created about 3,500 to 5,000 years ago, when about half of the parent body disintegrated and fell into dust. The cloud eventually evolved into Earth's orbit, causing a shower with peak rates of about 5 meteors an hour and some outbursts of bright flaring comets, radiating out from the constellation Capricorn towards the south. The bulk of the comet's debris won't be in Earth's path until the 24th century, by which time the Alpha Capricornids are expected to become a major annual meteor storm, stronger than any current annual shower. Jonathan Nally, the editor of Australian Sky and Telescope magazine, joins us now for the rest of our tour of the July night skies.
G'day, Stuart. Yeah, well, it's winter time, middle of winter here. We are in the southern half of the planet, and it's cold. It's cold, but where I live, at least, the skies are usually pretty nice and clear this time of year. So it's really good for stargazing if you get out and rug up. And we've got some of the best southern constellations up nice and high in the sky this time of the year in the early evening when you can get out and do some stargazing. So we've got the Milky Way, which is our galaxy seen from the inside. It's stretching all the way from the east to the west across the sky. From where the sun comes up to where it goes down, that's east to west, and that's in the middle evening or early evening, and it's got stacks and stacks of things in there to see. So right in the middle of that stretch of the Milky Way, and basically high in the south, we've got the Southern Cross. Southern Cross, famous Southern Cross, very small constellation, but a very prominent constellation. It's at its highest point in the sky at this time of year. So if you haven't seen the Southern Cross yet and you want to try and identify it, now's the time to get outside and have a look, because at 6 months from now, it's going to be down very low in the sky and you might not be able to see it at all. So winter's a good time to see the Southern Cross. Just to its left, we've got two bright stars, and they're known informally as the two pointers, because if you draw a line between them and you extend the line further, it basically points directly towards the Southern Cross. Those two stars are called Alpha and Beta Centauri. And listeners who are of the right age will remember that Alpha Centauri was the destination of, Stuart, what was the destination of?
Danger, Will Robinson. Danger, Will Robinson.
You babbling booby, yes. The Jupiter 2 spacecraft in the TV show Lost in Space.
Oh, the pain. The pain.
Oh, they don't make them like that anymore, do they?
The pain.
They probably couldn't make them like that anymore. Anyway, they must have really become lost in Lost in Space, because the Alpha Centauri star system, of course, is the nearest star system to our solar system, and there's nothing in between. So how on earth they got lost between here and there, and there's nothing in between? They must be, oh, that's right, they got thrown off course, didn't they, because it was a stowaway. And then how many series did they get out of that? It seemed like it went on forever when I was a kid, but it was a really good show.
According to Google, Lost in Space had only 3 series, roughly 29, 30 and 24 episodes in those 3 series, 1965 to 68. What else do we need to know?
Well, that's quite a few episodes per series. So that probably is the reason why it just seemed to go forever, because it was always on telly. And then, of course, as soon as the series finished, they just kept repeating it.
But you know what I hate? They never had a proper ending. What I liked about Star Trek is that there was an ending to the genre when each of the series finished. There was a final episode for Next Generation and for Deep Space Nine and also for Voyager. But we never had that with Lost in Space. It just ended in midair, well, mid-space, I guess.
Well, that's the thing with Lost in Space. It was the suspense of not knowing what was going to happen next. That was the whole point of being lost.
But
whereas
they should have had a conclusion. They should have reached their destination or returned safely to Earth.
No. This sickly, cloying Star Trek nonsense. I'm not a Star Trek fan, you'll know. Where they have to wrap up everything nicely and everyone's lovey-dovey, whatever, whereas Lost in Space was more reality. Half of them hated each other's guts and didn't trust each other, and it all went wrong, and that's life, isn't it, basically? Anyway, Alpha Centauri. So that's down in the south. Alpha is the 3rd brightest star in the night sky, actually. Beta Centauri, just next to it, is the 11th brightest star in the sky. The Southern Cross I mentioned, 2 of those stars are very bright as well. One's the 12th brightest, and the other's the 20th brightest in the night sky. Now, rising high in the eastern half of the sky, this time of year, we've got the constellation Sagittarius and the region around it, and its neighbouring constellation Scorpius. And both of these constellations are full of great stuff to see with the telescope or even just binoculars. You've got star clouds and star clusters, and you've got nebulae, and it's just superb. And the reason for this is that when we're looking in this direction in space, we're looking right into the middle bulk of our galaxy, where most of the stuff of our galaxy is. There's lots of stars and things in there. So the center of the Milky Way, in fact, is located in the direction of Sagittarius. So that's starting to come up now in the eastern half of the sky. So we've got months and months and months to have a look at all that. Right down low, actually, in the southeast, at this time of the year, there's the 2nd brightest star in the sky, Canopus. But you have to be quick to see it because it sinks down below the horizon by about 9 p.m. So if you see a bright star down on the southern horizon and you go out 7 or 8 o'clock when it gets dark, that's the star Canopus, the 2nd brightest star in the sky. Yeah, up in the northern half of the sky, we've got a few bright stars. We've got one called Arcturus, and another one called Altair, another one called Vega. Arcturus is the 4th brightest star. Altair is the 13th, and Vega is the 5th brightest star in the whole night sky. Now, all of these brightness rankings are just how we see them from Earth. their actual intrinsic brightnesses are actually different. How we see them just depends on how far away they are. So Vega, for instance, which I said is the fifth brightest star, it appears to be brighter than this star in the Southern Cross called Mimosa, but in fact Mimosa is a far brighter star, it's just further away. So Vega is only 8 light years away, whereas Mimosa is 350 light years away. So this difference between what astronomers call apparent brightness, how bright it appears to us, and intrinsic brightness, how bright something would appear if it was seen from a standard distance. That's the two measurements of brightness that astronomers use. Now let's take a look at which planets we can see. And just like last month, actually, all of the bright planets will be stretching across the morning sky. So if you go out before sunrise, about 30 minutes before sunrise, you should be able to spot Mercury, if you've got a good clear horizon, very, very low down on the sort of northeasterly horizon from where we are. Just a little bright star-looking thing, probably in a bit of the dawn glow already. And then above it and to its left, Venus. You can't miss Venus. It's the biggest and brightest thing in the sky other than the sun and the moon. Go up a little higher and more to the north and you'll find Mars, which can be identified quite easily because it's got quite a distinct reddish sort of colour. Higher still, and a bit west of north, you'll spot Jupiter, which is big and bright, although not quite as bright as Venus, but pretty bright. And then further around towards the west and about the same height above the horizon as Jupiter, you'll see Saturn, which you can tell because it's got a slightly yellowish tinge.
That's Jonathan Alley, the editor of Australian Sky and Telescope magazine. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.